Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL May 2022 paper 1 time zone 1 past paper. Today we will be solving the last question of this paper, that is question number 12. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring classes. So without any further delay, let us start answering question number 12. The maximum mark is 21. It is containing 5 subparts. I have just brought in the first one over here. The function f is defined by f of x equal to e to the power of x times sine x, where x belongs to the set of real numbers. Subpart A says find the Maclaurin series for f of x up to and including the x cube term. It is containing 4 marks. So you will be having the Maclaurin series given in your formula booklet, but I am writing it over here. F of x, it will be an infinite series. This is f of 0 plus x times f dash 0 plus x squared over factorial 2 f double dash 0 plus x cube over factorial 3 triple dash 0, that is the third derivative, plus x to the power of 4 over factorial 4, the fourth derivative, and so on. Okay. It is an infinite series. And we have to give up to x cube. So, we have to get the expressions for f dash, f double dash, f triple dash. First of all, let us get these expressions. And f0 is what? We need f0. f0 is equal to e to the power of 0 times sine 0, which is equal to e to the power of 0 is 1 and sine 0 is 0, so it is 0. Okay. Now we come to f dash. F dash x equal to e to the power of x sine x. We are using the product rule, of course, plus e to the power of x cos x. Okay. This can be written as e to the power of x sine x plus cos x. So, f dash 0 is equal to e to the power of 0 and sine 0 plus cos 0. Sine 0 is 0, cos 0 is 1. E to the power of 0 is 1, therefore 1 times 1 is 1. Okay. Next is f dash, double dash. I'm taking this one. Again, the product rule, it is e to the power of x sine x plus cos x plus e to the power of x cos x minus sine x. Okay, so or let me just simplify this further. This is e to the power of x sine x plus cos x plus cos x minus sine x. So this is equal to 2 e to the power of x cos x. Okay. And then if double dash 0 should be equal to 2 times e to the power of 0 times cos 0. So e to the power of 0 is 1 and cos 0 is 1. So this is equal to 2. This is 1, this is 2, that one was 0. Coming to f triple dash x, the third derivative. I'll be differentiating this one. So it is 2 e to the power of x cos x minus 2 e to the power of x sin x. Okay, which is 2 e to the power of x cos x minus sin x. Okay, fine. So therefore f triple dash 0 is equal to 2 e to the power of 0 and cos 0 minus sin 0. Sin 0 is 0, cos 0 is 1, and e to the power of 0 is 1, so it is also equal to 2. Okay, fine. So now we come to the f of x. Therefore, f of x equal to, let me write this, e to the power of x times sin x. This is equal to, if 0 is 0, so I'm leaving it. I'm not writing 0 plus, doesn't have any meaning. So it is x times f dash 0. F dash 0 is 1. Or I can write it for the first time. I can write this as 0 plus x times 1 plus x square over factorial 2 times f double dash 0 is 2 plus x cube over factorial 3 is 6. This is equal to 2. So these two will be getting cancelled. And times f triple dash 0 is 2. And this is dot 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 actually. Okay. So this is equal to x plus x square plus x cube over 3 plus dot dot dot. Okay. So this is our answer for the subpart A. Let us move on to the subpart B. Subpart B. Hence, find an approximate value for the integration between 0 and 1 from 0 to 1 of e to the power of x squared times sine x squared with respect to x. So, we have in our first subpart, that is subpart A, we had found this e to the power of x times sine x to be equal to this. We had written only the first three terms because we were asked to get terms up to x cube, but it is in fact an infinite series. And because they have said an approximate value, that is why we can take the first three terms. Otherwise, we couldn't have taken. Okay. So this is e to the power of x sine x. Therefore, what will be e to the power of x square sine x square? It will be e to the power of x square times sine x square should be approximately equal to, in place of x, we will be writing x square. So x square plus x square to the power of 2 plus x cube to the power of 2. Oh, sorry. This should be x square to the power of 3 and over 3. So this is approximately equal to this. And what is this equal to? X square. X square whole square is x to the power of 4. And this one is 2 times 3 is 6. So it is x to the power of 6 over 3. Okay. So this is an approximate expression. It is definitely not an accurate expression because we have taken just the first three terms. And we will be integrating this. Therefore, integration of this is approximately equal to the integration of this part. Okay. So this is equal to x cube over 3 plus x to the power of 5 over 5 plus x to the power of 7 over 7 times 3 is 21. 0 to 1. Okay. So this is equal to 1 over 3 plus 1 over 5 plus 1 over 21. Okay. Because x equal to 1, and for 0 all the terms will be 0, so I'm not writing that, or I can write just minus 0. Okay. So what will the common denominator be? What will be the LCM be for these three numbers, 3, 5 and 21? The LCM of 3 and 21 is 21. And what is the LCM of 5 and 21? It has to be 105. So let us take 105 as the common denominator. Okay. And this is what? This one is 35. 3 times 35 is 105. So this is 35. And this one is 25 times 21 is 105. So this one is 21. And this one is 21 times 5 is 105. So this one is 5. Okay. So 35 plus 5 is 40. 40 plus 21 is 61. 61 over 105. Okay. And it is not divisible. This 61 is not divisible by 5. It is not divisible by 3. It is not divisible by 7. So we don't have, we cannot simplify this anymore. So this will be the answer. Okay. 61 over 105. This is the answer for this integration, the approximate value. Okay. So let us move on to the subpart C. The function g is defined by g of x equal to e to the power of x times cos x, where x is a real number. And subpart C says that it has two further subparts. I says, so that g of x satisfies this equation g double dash x, that is the second derivative of g of x, equal to 2 times the first derivative of g of x minus g of x. Okay, so, okay, fine. So, let me start over here. This is the I. What is the first derivative of g of x? It is, we'll be using the product rule, of course. So, e to the power of x cos x minus e to the power of x sin x. This is e to the power of x cos x minus sin x. And the double dash, what is that? Second derivative. So this is e to the power of x cos x minus sin x plus e to the power of x minus sin x minus cos x. Okay, fine. Okay, let me leave it like this and let me just come to the right hand side of this part. This equation. What is 2 times g dash x, the first derivative, minus g of x? It is 2 times, the first derivative is this, e to the power of x cos x minus sin x. or let me not take this, e to the power of x cos x minus e to the power of x sin x. Okay. This is the g dash x, and g of x is e to the power of x minus, so minus e to the power of x cos x. Okay. So these two will be getting cancelled. And we are having this as minus 2 e to the power of x sin x. Fine. So we have to simplify this further. This is my e to the power of x cos x minus e to the power of x sin x minus e to the power of x sin x and minus e to the power of x cos x. So these two will be getting cancelled, and we will be having this as minus 2 e to the power of x sin x. Okay. Therefore, g double dash x, the second derivative of g of x, is equal to 2 times g dash x minus g of x. Okay. So this is the answer for the subpart I, and then I come to the subpart II. Drawing a line like this. So this is II. Hence, okay, so we have to use this. Hence, deduce g to the, this is the fourth derivative of g of x equal to 2 times the third derivative of g of x minus the second derivative of g of x. Okay, so we have got this equation. We will be using this equation to get the, first of all, to get the third derivative and then the fourth derivative. So therefore, the third derivative of g of x should be equal to 2 times this, when differentiated with respect to x, will be giving us the second derivative. And this one will be giving the first derivative. And now we are differentiating again with respect to x the whole equation. So we get this one on differentiating. Okay, let me write it after. Equal to 2. This is the third derivative. This will be the third derivative minus the second derivative. We get this. We get the above expression by differentiating g double dash x equal to 2 times g dash x minus g of x twice with respect to okay. So we have answered the subpart C completely. Let us move on to subpart D. Subpart D. Using the result from part C, the results from part C, the g of x was given as e to the power of x times cos x. G dash x, the first derivative, was e to the power of x times cos x minus sin x. The second derivative was 2 times g dash x minus g of x. The third derivative was 2 times g double dash x, that is the second derivative, minus the first derivative, and the fourth derivative was 2 times the third derivative minus the second derivative. Okay. Find the Maclaurin series of g of x up to and including the x to the power of 4 term. So, g of x equal to e to the power of x cos x is equal to g of 0 plus x times g dash 0 plus x square over factorial 2 g double dash 0, that is the second derivative, plus the third derivative is x cube over factorial 3 times the third derivative plus the fourth derivative x to the power of 4 over factorial 4, because they have asked us to take the term up to x to the power of 4. So this will be g to the power, the fourth derivative. And in fact, this is an infinite series, so it is plus dot dot dot. Okay. So now we have to get the values. This is equal to g of x, g of 0. So this is e to the power of 0 cos 0. E to the power of 0 is 1 and cos 0 is 1. So g of 0 is 1 plus x times, what is g dash 0? Let us solve over here. G dash 0 equal to e to the power of 0 and cos 0 minus sin 0. Okay. Sin 0 is 1, so sorry, sin 0 is 0, so cos 0 is 1, so this is 1 times 1 is 1. So this is times 1 plus x square over factorial 2 is 2 times g double dash 0 will be what? This is 2 g dash 0. G dash 0 is 1 minus g of 0. G of 0 is 1. So minus g of 0, so 1 minus 1. So this is equal to 0. Okay. So this is equal to 0 plus x cube over factorial 3, which is 6 times, let me get the g triple dash 0 over here, is equal to 2 times g double dash 0, which is 0, minus g dash 0. G dash 0 was equal to 1. Okay. So this is equal to minus 2. So this is minus 2 plus x to the power of 4 over factorial 4. So 3 factorial is 6. 6 times 4 is 24. And what is the value of the fourth derivative? And x is 0. It is equal to 2 times third derivative is negative 2 and the second derivative is 0. So this is negative 4 and plus dot dot dot. So this is equal to 1 plus x square. Oh, sorry. This is 0. So, and this is in fact not plus, it is a minus. So this is x cube over 3. And this is also minus x to the power of 4 over 6, and so on. So this is the expression for g of x, or e to the power of x times cos x, up to the term containing x to the power of 4. It is an infinite series. Okay. So let us move on to the last subpart of this question, that is the subpart E. Subpart E, hence or otherwise, that means you may use the information that we have found in the previous 4 subparts, or else you may use some other method as well. So determine the value of limit x tends to 0, e to the power of x times cos x minus 1 minus x over x cube. Okay, otherwise means it may be, you may use the L'Hopital's rule, because this denominator will be 0 cube is 0 when it is almost equal to 0, not equal to 0, because x is tending towards 0. It is a very, very small number, but not equal to 0. Okay. And this is e to the power of x means almost equal to 0. This will be 1. Even this will be 1. 1 times 1 is 1 minus 1. So they will be cancelling. And this is minus x. So this will be 0 over 0 k. So you can use the L'Hopital's rule as well, or else you can use the Maclaurin series. So I am using the Maclaurin series, and we have found the expansion of this e to the power of x cos x in our previous part, that is part D. And we had found the first 4 terms as 1 plus x minus x cube over 3 minus x to the power of 4 over 6. And as you go to the higher terms, the power of x will be just going on increasing. And if you have a very small number, x tends to 0, say maybe like if you have a fraction, say x equal to half, it is not at all near to 0. Okay. But even if I'm having x equal to half, it is smaller than 1. So x square will be equal to 1 over 4. So 1 over 4 is less than half, right? X cube is equal to 1 over 8. 1 over 8 is less than 1 over 4. So as the power of x goes on increasing, the value goes on decreasing. So the term values will be going on decreasing as we move on to the higher terms. So we can safely ignore those higher power of x terms. Okay. We may take only the 4 terms that are available to us, that we have found using the Maclaurin series. So we can write this as limit x tends to 0. In place of e to the power of x times cos x, I am writing these 4 terms. So 1 plus x minus x cube over 3 minus x to the power of 4 over 6 minus 1 minus x over x cube. This cancel, this cancel. So you have limit x tends to 0 minus x cube over 3x cube and minus limit x tends to 0 x to the power of 4 over 6 over 6 x cube. Okay. So these two will be getting cancelled. And since you don't have any x remaining in this part, it is negative 1 over 3. This is equal to negative 1 over 3. Doesn't matter what is the value of x. But for this, as x tends to 0, this fraction, this term becomes equal to 0. Very small, almost equal to 0. So we can neglect that. So the answer is negative 1 over 3. because this part is equal to 0. So this is the answer for the subpart E. So with this, we complete answering the question number 12. And thank you for staying with me till the end. I'm Nilanjana Sanyal. I'm an online IB Math A, SL and HL level tutor. I tutor students from both within India and outside India. And I offer both one-on-one and small group online tutoring sessions to my students. And right now, as you are seeing, I am solving the IB Math A HL past paper questions. I'm recording them, and I am uploading these videos in my YouTube channel. So in case you are liking my explanations, please to give these videos likes, and please to share these videos with your friends so that even they can get benefited by watching these videos. And in case you are having some doubts, any confusion, any query, please feel free to write to me in the comment section. I will be trying to answer and solve your doubts. So, and please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. Okay? And we will be meeting very soon in our next session, where we will be solving in fact, we will be taking up the next paper, that is the paper 2 times zone 1, and we will be solving the question number 1 of that paper. Okay? In our next session. So till then, bye.